Hello! This time we've got 3 exam-style questions. We've got one about an exponential function on a log set of coordinates. So it's been made into a straight line, so presumably we're going to have to muck about with that a bit. We've then got an equation with x in the power. So again, that feels like it's going to be logs of some sort. And then we've got a differential here, f dash of x, and we're having to integrate it into f of x, and presumably there's going to be some cutting it up and mucking about, and so on and so forth. So we'll make a start on question 7. Population p, blah, 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 blah. The equation here, that's the key thing. There's 2 kinds. There's the kind where the t is in the power, and so you end up having just t on its own. Notice this has been logged, but this one hasn't. And there's another version where you end up having to have this as a log as well for it to work. But anyway, no matter. Just start off with this. And I haven't actually read the question, but whatever. P equals a b to the t. If we just take logs of both sides, we're going to get log base 10. I'm not going to bother writing. Log of p equals log of a b to the t. We've got to split that a, b up. We can't move the power until we've split the a and the b up. So this equals log a plus log b to the t. And then this will equal log a, and then the power come out, plus t log b. So I'm just going to bear that in mind as I now go through. Got some numbers there that we might need, not sure. Write down an equation of line L. Okay, well actually that's got nothing to do with the log so far. We just want an equation of a line. We can get the gradient from here. It's going to be the rise, which is from 2 to 2.2, so that's 0.2, over the run, which is 20. And if we multiply, but we can cancel the 2's, and then we can take, that's 1 over 100, I think. And then we can say that it's y minus 2 equals 1 over 100 x minus 0, so just x. So y equals x over 100 plus 2. Work out the value of a and interpret this value in the context of the model. Well, this is where it's important that we've done this. So if we look at how this relates, our y is actually the log p. So that is the axis, so that is that one. T log b, well, the t is the x. So that's the gradient is log b and the t. So the gradient is 1 over 100 and the x is the t, which means our log a is just this number 2. So if log to the base 10 of a equals 2, then we can easily work out a equals something. So that's 100. And interpret the value in the context of the model. So for that, we need to come back up to this thing that we started with. If we think about this, this is a value a, and then it's multiplied by b to the power of t. So every time t goes up by 1, as this, I presume it's time in month. Okay, time in months. So every month, that t is going to go up. So that b gets times by more b's, it's raised to a higher power, and then the whole thing is times by a. So in this context, you've got to think, okay, well, what happens when there is no t? When t is 0, b to the t is 1, and 1 times a is just a. So this value is the initial number of owlet nightjars or something. Whatever it is. It's the starting amount at time equals 0. It's the initial amount of things. Work out the value of b and give your answer correct to 3 decimal places. So we've got that log b is 1 over 100. So you just have to inverse log that, or 10 to the power of 1 over 100. I'll let you do that. Find the population predicted by this model where t is 30. Well, now we know what b is and we know what a is. We can just shove those into here. It's just going to be 100 times that value of b that you've just worked out to the power of 30, and then bosh that into the calculator. Any problems with that? If I've made any mistakes, then let me know in the comments. Otherwise, we'll move on to question 12. Also a bit loggy, but actually quite different. In this case, I'm not needing to take logs. If I can actually, it's more indices. If I can make the base numbers the same, then the powers must be the same. And I know that 9 is 3 squared. So this is 3 squared to the power of 2x. And this equals, now 27 is 3 cubed to the power of x squared minus 5. Now, when you raise something to a power and then raise it to another power, you multiply the powers together. So this is 3 to the power of 4x equals 3 to the power of 3x squared minus 15. And now that the bases are the same, then the powers must be the same. Now you could log it. You could log both sides and then bring the powers to the front and then cancel the log 3's. But I can just say, well, if the numbers are the same, the base is the same, then the two values, the two powers must be the same. So we can just say 4x equals 3x squared minus 15, or indeed 0 is 3x squared minus 4x minus 15, and then solve the quadratic, which I will leave you to do. Again, if I've said anything crazy, you let me know, or if I haven't explained something, then tell me in the comments and I will do something about it. Question 14, our last question. We've got a differential. We need to show that it can be written, that the equation, so integrate it, and it should look like this, and plus c at the end is the constant. Fine. So the key thing here is that I'm not going to be integrating this fraction. And okay, in second year, you learn how to deal with some things like this. But in this case, because it's just a single term as the denominator and all the variables match, we'll just split it up. It's going to be the easiest thing, just like as a polynomial. So f dash of x is going to be root x over x squared minus x squared over x squared minus 1 over x squared. Or, slightly better, this is x to the power of a half instead of the square root. So a half minus 2 is x to the minus 3 over 2. This is cancelling out to give us 1, and then this is minus x to the minus 2. And now it's just really easy to integrate this and just do the standard increase the power and divide. Is that the right way around? Differentiation would be times the front by the power and reduce the power by 1. So yeah, we add to the power first and then divide. So f of x is going to be, so increase that by 1 and then divide, so it becomes minus 2, and then that just becomes x, and then that we're going to increase the power by 1, and then we're going to divide, so it becomes plus, and then we can say, okay, well, we need to write it in this form. So we're kind of like factorizing out an x in this case, aren't we? We're sort of saying, okay, if I bring out 1 over x, what does that do to everything? Or the other way to think about it is, so that I can put an x on the bottom, I'm going to times everything by x. If I times the denominator by x, I times the numerator by x. So I'm just going to go along the line doing that. So times this by x is going to add 1 on, so it's going to be minus 2x to the half. Whoopsie. Times that by x is going to be x squared, and times that by x is going to just be 1. Now this looks good. We've got the 2 root x, the x squared and the 1, but I've got the sign. No, I haven't. I thought I had the signs wrong, but there's a cheeky little minus there. So we can factorize that minus out and say minus, and then put it in the way that they've got it. Very sneaky. And over the x. There. Now it says, given that this function passes through the point 3 minus 1, find the value of c. Oh, I forgot the plus c. And they even told me to do it as well. That's very foolish, but at least I noticed before I handed my paper in, so that's all good. Find the value of plus c. Well, we know how to do that. Let's just make a bit of space. We've got to put the values in and just solve for the plus c. So we can say that f of x is going to be minus 1, and this equals, so what's it going to be? It equals minus 3 squared, so minus 9 plus 2 root 3 minus 1 all over 3 plus c. Yeah, and then I was going to say this is going to, I can't get rid of that root, but it's okay because it says give your answer in the form p plus q root r. So that's fine, we can do that, no problem. So we'll say that minus 3 equals minus 9. Oh, no, got to expand out that minus sign. That was close. That was a plus. That's minus 2 root 3 plus 1 plus 3c. We don't actually need this bit anymore, because it was a show that anyway. So that's another thing. If you couldn't do that first bit, I hope you had a go at the second bit, because that's the whole point of a show that is that's the answer. So just use that in the second bit. Okay, and then we still need to rearrange all of this. So we can put these together. Let's move this over and have that as 6. Take away the 1, so let's have that as 5 plus 2 root 3 equals 3c. It says p, q, and r are rational numbers. It doesn't say integers. Rational, so fractions are fine. So it's going to be that c is 5/3 plus 2/3 root 3. Seems plausible. I'm sure you'll tell me if I've made any mistakes, but that is certainly how I would go about doing it. I'm pretty sure my methods are all good there. If I've made silly numerical mistakes, I do humbly apologise. I look forward to you telling me about that in the comments. Any other questions, anything I didn't explain properly, you let me know. Otherwise, ta-ra for now.